It's been 20 episodes since we introduced fraction multiplication, and we're only now getting to division?
What the flip, dude? What the flip, dude? What the flip, dude?
Hello everybody, and welcome back to Maths. We're finally here. We're finally at dividing fractions. We've spent I think 20 videos doing stuff with fraction multiplication, and it's been a fun ride. We've covered a lot of different forms that it comes in, a lot of interesting applications, and today we are going to expand what we can do with fractions by now being able to divide them. And to be honest, it's pretty much the exact same thing as multiplication. There's just one little thing added in there. So hopefully you'll be pretty comfortable with the idea pretty quickly. That being said though, this seems to be one of those topics that students tend to forget, or they never know really how to deal with dividing by fractions. I see this happens a lot, even with more advanced students. Dividing by fractions seems to be what always trips them up. So really take your time watching this video, do a lot of practice, and try and really lock these ideas in so that you don't become one of those poor students.
Fraction division.
Alright, so to start with dividing fractions, let's maybe consider what we know about the arithmetic operations. So that's plus, subtract, multiply, and divide. So first of all, we know that addition and subtraction are opposites, right? Alright, so for example, if I start with 3 and I add 2 to it, I get to 5. But then if I subtract 2 from 5, I get back to 3, right? So basically adding 2, subtracting 2, it's just this kind of cycle that goes around, and they just keep undoing each other because they're opposites, right? And another way we saw that this worked was with number line shifting. So this goes way back to the first episodes of the Fundamentals of Algebra series. But we saw that one thing we could do is we could take a copy of the number line and slide it over. And if we slid it to the right, that corresponded with addition, right? 0 lines up with 1, 1 lines up with 2, 2 lines up with 3, and so on. Or if we slid it to the left instead, that would correspond with subtraction, right? So 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, so on and so forth, right? So we see that essentially addition and subtraction were actually the same type of action, right? The sliding of the number line, just in different directions. Right, so we have this idea that addition and subtraction are opposite of each other. And we also have a similar idea for multiplication and division. If I take 3 and I multiply it by 2, I get 6. But if I take 6 and I divide it by 2, I'm going to get back to 3, right? So multiplication and division kind of undo each other. They're opposites. And we saw this also worked with the number line, except it wasn't slotting, it was stretching and compressing this time. So we could take this number line, and if we fix it at 0 and we stretched it out by 2, right, we see 1 would line up with 2 because 1 times 2 is 2. Negative 1 would line up with negative 2. A half lines up with 1, right? A half times 2 is 1, and so on and so forth. Or we could compress the number line, right? So we could make all the distances between these gaps to be 2 times smaller if we're dividing by 2, right? So we get that negative 2 divided by 2 is negative 1, or 4 divided by 2 is 2, and so on and so forth, right? So we see that multiplication and division corresponded to the same type of action, right? Kind of this pulling or pushing, but just kind of in different directions, right? You're either stretching it or you're pushing it back in. And so that kind of affects the distance between these ticks here. So they're kind of two sides of the same coin. So since we know that multiplication is the opposite of division, and vice versa, division is the opposite of multiplication, well, we can figure out what fraction division should look like by considering what's the opposite of fraction multiplication. So we know from the 2 birds, 1 fractions video, if you haven't seen that, please go watch it, because this is going to be essential to really understanding the motivation behind fraction division. We saw in that video that we can think of fraction multiplication as a double action. So for example, if I took 3 and I multiplied it by 3/4, this process of multiplying by 3/4 had 2 kind of pieces to it. It had the multiplication by 3, or the stretch by 3, and it had the compression, or the division by 4. So kind of encoded into this multiplication by a fraction, there's a stretch component and there's a compression component. All right. So since we have that, how do we basically do the opposite of this, right? Because we're looking to divide by this. Well, it would make sense then to undo the stretch component. We compress by it instead. So instead of stretching by 3, what if we compress by 3? And instead of compressing by 4, to kind of do the opposite of that, we would want to stretch by 4, right? So what's going to end up happening is that the compressing by 4 becomes a stretch by 4, if we want to do the opposite. And the stretch by 3 becomes a compression by 3 if we want to do the opposite. And what this gives us is it gives us basically a fraction where it's been flipped, right? Where the 4 that was in the denominator, which corresponded to a compression, goes into the numerator because now it's a stretch, right? That's the opposite. And similarly, the numerator, which corresponded to a stretch in the original action, now corresponds to a compression in the new action, right? So essentially, doing the opposite of multiplying by 3/4 corresponds to multiplying by 4/3. And this is exactly how fraction division is going to look. So if I wrote what is 3 divided by 3/4 is going to be multiplying by the flipped version, which is going to be multiplying by the 4/3, right? Because dividing by 3/4, that's the opposite of multiplying by 3/4. So we're doing the opposite of its double action. And that gives us, instead of a compression, a stretch by 4, and instead of a stretch, a compression by 3. So this is how you divide by fractions. It's as simple as this. You just convert it into a multiplication problem. And this flipped fraction, so the 4/3 is what we call the reciprocal of 3/4. So when you take a number and you do the reciprocal of it, that's just flipping it, essentially, if you regard it as a fraction. So the reciprocal reverses the double action of a fraction. So for example, the reciprocal of 3/4, we just saw that was 4/3. The reciprocal of -7/3, well, reversing these roles, right? So reversing the stretch by 7, that makes it a compression by 7, and reversing the compression by 3, that makes it a stretch by 3, and we still have to include the negative here. So that would be the reciprocal of -7/3. We could also try something like the reciprocal of 2. So you might think, well, this isn't really a fraction, but we know from fraction multiplication, we can regard 2 as 2/1, right? That was a common trick we had. So that means the reciprocal of 2 is actually just going to be a half, right? And it works going backwards, right? If we know that the reciprocal of 2 is a half, that means the reciprocal of half is 2. And the reciprocal of 3/4 was 4/3, so the reciprocal of 4/3 is 3/4, right? All right, so then we can basically summarize fraction division as follows. Dividing by a fraction is the same as multiplying by its reciprocal. And that's all there is to it. So now let's do some examples, because there's a couple cases where this might look a little bit different, where the form looks a little bit different, but ultimately, this is the fundamental concept that's going to be underlying everything here.
Examples.
All right, so what if I had 2 divided by 3/2? Well, we know that division is the same as fraction multiplication, right? We're just doing the opposite of a stretch by 3 and the opposite of a compression by 2. So we're multiplying by a stretch by 2 and a compression by 3, right? So this is going to be 2 times 2/3. We know that's the same as 2/1 times 2/3, because now we can just multiply the numerators and the denominators, and there's your answer, right? So we just convert it into a multiplication problem, and it's the exact same thing. It's nice and easy now, right? So if I do a 7th divided by 4/7, let's see what I get. Well, I'm dividing by 4/7, so that's the same thing as multiplying by the reciprocal, which again, we're just flipping the fraction, so that's multiplying by 7/4, and what we get is 7/28, which simplifies down to 1/4. All right, so that is the answer there. All right, let's try another one. So with this one, it looks a little bit different, but it's the same kind of idea. So essentially, when I use the diagonal bar for the fraction, that kind of indicates this fraction is inside of the bigger fraction, and the bigger fraction I indicate by using the straight bar like that, the straight fraction bar. So this is kind of a common way to put fractions inside of fractions. So this is the exact same thing, because remember, fractions are the same as division. This is the same thing as doing 3/10 divided by 5/2. It's the exact same setup here. It's just written in a different form. And we know that is the same thing as 3/10 times 2/5. and this is 6 over 50, which simplifies to 3 over 25. All right, what if we had negative a third over 60 over 23? All right, so we've got a negative in here, but again, that's fine because we're just doing a negative divided by a positive. So ultimately our answer is going to be something negative. So we have negative a third, and again, inside of this fraction, this is the same thing as just dividing by what's in the denominator, which is this 60 over 23. So that's negative a third times 23 over 60. All right, now it's a familiar problem, right? We just have negative 23 over 180, and that is as simplified as that fraction is going to get. And we could also have something that maybe looks a little bit weird, like 5 over a quarter. So now it's not like a fraction in the numerator and the denominator, but we still have a fraction in the denominator, which means that we're dividing by a fraction, right? So this is going to look like 5 divided by a quarter, which is the same thing as 5 times the reciprocal of a quarter. But the reciprocal of a quarter is just 4 over 1, which is just 4, right? So we're really just doing 5 times 4, which is 20. So dividing by a quarter actually corresponds with just multiplying by 4. All right. So there's one more kind of case where we could have fraction division, and this one usually trips people up a lot.
Fraction division by a whole number.
All right, so what if we have a fraction divided by a whole number? So for example, what if I had 3/7 over 4? Now, what some people might be tempted to do is to say, oh, we got a 7 over 4 on the bottom, that's our denominator, so we'll just take the reciprocal of that and go on our way. But that's not true. Remember I said we kind of look at the diagonal bar first before we look at the horizontal one? What this means is this is really the same as 3/7 divided by 4. It's not the same thing as doing 3 over 7/4, right? We kind of think of this as one thing, and that because it's separated by the horizontal bar, and this is the denominator, right? So our 3/7 is our numerator, so we can't simply just split off the 7 and the 4 separate from the 3, because the 7 is really being involved with this 3 first. So we have 3/7 here, and we're dividing it by 4. And again, this is the same thing as 4 over 1. So kind of like when we had a whole number multiplying by a fraction, we could regard the whole number as essentially being a fraction out of 1. We're going to do the same thing with division, because then we can take the reciprocal of this, right? So this is 3/7 multiplied by 1 over 4. And then we're good to go. We just multiply that out. We get 3 over 28, and that is our answer. Let's try another example. What's a half over 5? Well, a half over 5, that's the same thing as just a half divided by 5, but that's the same thing as a half divided by 5 over 1, which is the same thing as a half multiplied by the reciprocal, which is a fifth, and we get a tenth. All right, so that's how we do fraction division.
Some shortcuts.
So we can slightly speed up these processes a little bit because we're going to be doing this a lot, so it's good to be a little bit efficient with it. So until you get super comfortable with it, go about where you actually explicitly write it as division and then you use the reciprocal and all that jazz. But one thing we could do, so let's look at the 3/10 over 5/2 example that we did up here. Instead of writing it as, okay, this is 3/10 divided by 5/2, oftentimes you can just jump right to taking the reciprocal, right? Because we know we're dividing by 5/2. If we recognize that, we can just immediately take the reciprocal. So that gives us 6 over 50, which is 3 over 25. So we save ourselves kind of this one extra step here that is not necessary. Again, if you want to write it, by all means, go for it, but it's common for people to just go right from here to there. Similarly, if you have something like 3/7 over 4, like we had here, instead of kind of doing all this stuff, because we know we have a fraction on the top and a fraction in the denominator, one thing we could do is just add this over 1 down here and then do the same process as above. Just write 3/7 times the reciprocal, because this is again the denominator, so that's going to be times the 1/4, and we get 3 over 28. But we could even go a little bit faster with this. If you get really comfortable with this and you see something like 3/7 over 4, then because this is a whole number, we're always going to be putting it over 1 and multiplying by the reciprocal, which means the numerator that we're multiplying from this is always going to be 1, right? If I have 3/7 over 5, I'm making a 5 over 1, and this is going to be a 1/5 when I look at that reciprocal. So we're always going to get a numerator of 1, which isn't going to affect anything. So it's also common for people just to immediately jump to this step here, where they take the 4 and the 7 and they just multiply the denominators like that. And this gives us 3 over 28. So we get the same thing regardless of the way we approach it, but you just may see it done in both ways. Just remember that ultimately what's happening is this process of you're making this 4 into 4 over 1, you're taking its reciprocal, right, because you're dividing by that fraction, and then you are multiplying that out, right? So I think part of the confusion people have with fraction division is that these common methods of approaching it, where we eliminate some of the middle steps, maybe it kind of hides some of the intuition for what's going on and people forget what they're actually doing. So you can use these, but you always have to make sure that you're understanding the fundamentals of what's going on. And that is you're dividing by a fraction, which means you're multiplying by its reciprocal, because that's undoing the double action, right? The stretch of the numerator becomes the new compression of the denominator. The compression of the denominator becomes the new stretch of the numerator, right? That's just that reciprocal action there. And then you're just multiplying it afterwards.
Concluding thoughts.
I hope you found that video useful. Now you should be a pro at dividing fractions. Of course, we're going to do a lot of examples with this, and this is going to be a concept you'll be using all throughout your mathematical career. So you will be doing this probably hundreds of times. I'm sure I've done it thousands. So with all that being said, you have a good one, you stay groovy, and I'll see you in that next juicy BOMaths video.
What the flip, dude? Seriously, what the flip, dude?
BOMaths.